Hello friends, welcome to my YouTube channel RJK Tutorials. So today I'm going to take a class on graphs and diagrams. Now graphs and diagrams play a very vital role in statistics. Now data analysis is one part of statistics and representation of statistical data is another part of the statistics. In data analysis, we'll be using certain statistical tools such as Z-test, T-test, ANOVA, all these things to analyze the data. So once the analysis of the data happens, you have to represent this particular data in a form which can be understood by a layman. So for that, we'll be using graphs and diagrams. Now, this particular presentation consists of two parts. The first part is on diagrammatic representation of data. The second part of the presentation contains the graphical representation of data. Now, what do you mean by diagrammatic representation of data? Now, let us see what you mean by a diagrammatic representation of data. It is the visual form of representation of data in which the facts are highlighted in languages of diagram. So what you mean by languages of diagram? Now, here we will be representing the statistical data by using certain geometrical figures such as bars, circles, rectangles, squares, pictures, maps, and charts. So when you represent this data, or any statistical data using these geometrical figures is called as the diagrammatic representation of data. Now, it will attract the attention of large number of people and it will facilitate the comparison between two or more sets of data. So these are the two unique advantage of diagrammatic representation of data. So coming to different types of diagrams, so basically there are five different categories of diagrams. They can be classified as one-dimensional diagram, two-dimensional or surface diagram, three-dimensional or volume diagram, pictogram or cartogram, or the map diagram. So like this, we have five different types of diagrams are there. Now, whenever you are drawing a diagram, you have to follow certain general rules. So what are those rules? So any diagram should have a proper title. The size of the diagram should be proper. That means it should not be very big or very small. And the proper scale has to be done. That means when you're drawing a diagram, you'll be using the x-axis and y-axis. So the scaling has to be done properly. So indexing is very much required. So when you are representing any data, the source of the data has to be highlighted. The footnote has to be given. It should look very attractive and it should be neat and it should be simplicity. That means it should be very simple. Any layman should be able to understand the diagram. So that is how you should represent the diagram. So let us see the different types of diagrams. What are the different types of diagram? We have one-dimensional, two-dimensional or surface diagram, three-dimensional or volume diagram, pictogram, and the fifth one is cartogram or map diagram. So coming to the one-dimensional diagram, so these are the diagrams where one-dimensional measurement is taken. For example, height of an individual or the weight of a individuals, or the you are selecting the heights of 10 students in a particular class. So when you're selecting 10 students, you're selecting based upon the height. In such cases, we're going to use one dimension. So when you're using one factor or one measurement, it is called as one dimensional diagram. So these diagrams may be in form of lines or bars. So there is no importance of the width or thickness in these diagrams. The height of these lines or bars, what you use for drawing the diagram, are taken on the basis of the values. That means bigger values are going to have a bigger lines on bigger bars. Smaller values are going to have a smaller lines and smaller bars. So for example, here the ages of three individuals are plotted here, Bob, Matthew, and John, by using a line diagram. So x-axis ages are taken and y-axis height is represented. Now since here we're going to take one measurement here, the height, it is called as the one dimensional diagram. So the best form of one dimensional diagram is line diagram. So in these diagrams, only line is drawn to represent one variable. So what is the variable we taken? Height is taken as the variable. These lines may be either vertical or horizontal. So line diagram is used in case where there are many items and there is least difference between the different values. That means if you want to differentiate three different values or four different values, and in such cases we can use the line diagram. So the construction of this diagram is very simple and it makes comparison very easily. You can see the different colors of the lines. So based upon that, you can do the comparison. So it has no width and hence of a very poor visual effect, so it is very less attractive. So one of the main disadvantage of line diagram is it doesn't have a width, so therefore the size of these lines cannot be altered or cannot be represented on a graph sheet, so therefore it may not look very attractive. In such cases you have to go for the bar diagram or the histogram. So next one is the bar diagram. So bar diagram is the easiest and most commonly used method. It consists of bars of equal width, all horizontal or vertical. That means bars can be either drawn on the x-axis or the y-axis. If you're drawing bars on x-axis, it becomes the vertical bar diagram. If you're drawing bars on the y-axis, it becomes the horizontal bar diagram. They make the comparison very easily, and different variables can be represented on the bar diagram. So the examples of bar diagram can be simple bar diagram, multiple bar diagram, subdivided bar diagram, percentage bar, duodirectional bar diagram, deviation bar diagram, broken bar diagrams. So like this, you have a different forms of bar diagrams. Now let us see the difference between a simple bar diagram and the multiple bar diagram. Simple bar diagram is used for comparative study of two or more items or two or more values of a single variable. Now this can be also drawn either vertically and horizontally, and here the distance between the bar should be equal. So that is one important criteria you have to keep in mind. Now, for example, here the sales, the profit data of a particular company over a period of time is represented. On the x-axis, you can see the various years are represented, starting from 1989 to 1993. So 89, 90, 91, 92, 93, and profit of the company in millions is represented by axis. So this is how the simple bar diagrams can be represented. In case of multiple bar diagram, here this diagram is used for making comparison between more than two variables. So if you have two variables or three variables or four variables, you can use a different designs of bars to differentiate or do the comparison. Now, for example, here you have a two different color bar, one representing the exports, the other representing the imports, and these exports and imports of a company is represented over a period of time. So in this way, the multiple bar diagram can be used for comparing between two or more variables. So this particular diagram is also known as the compounded bar diagram because we are going to use the different variables to do the comparison. The third type of bar diagram is called subdivided bar diagram. This is also known as component bar diagram, or it's also known as the stacked bar diagram, and is used in representing the total of the data, their main parts, divisions or components. Now here you can see all the data is stacked one above the other. So therefore it is also called as the stacked diagram or subdivided diagram. Instead of representing different data in different bars, all these different data can be represented on one bar, one above the other. So that is what we're going to do in the subdivided bar diagram. Now here you have the quantity of production of the meat of various animals, rabbit, lamb, pork, beef, and chicken. So this data is represented one above the other. So here we're going to measure the moisture, fat, and cholesterol. So that is how we can represent the different data one above the other. So in case of percentage bar diagram, so it is similar to the subdivided bar diagram, but you're going to take the values in percentages. So that is the values are converted into percentages. So these values are stacked one above the other. So that is how the percentage bar diagram is represented. Now here you can see in the example weekly product sales of the hardware and software and services. This data is stacked one above the other, but here the overall sales of this data is converted into percentages, and these percentages are represented in the bar diagram. So that is why it is called as the percentage bar diagram or percentage stacked bar diagram. So what are the various uses of bar diagram? So as I said earlier, it is used for comparing the two or more data, and the data can be very beautifully can be represented on the graph sheet. So it looks more attractive, and you can put the data values. You can see some of the values on the top of the bar. So these are called as the data values. So by seeing the data values, we can understand what exactly the data is represented on the bar diagram. Now, apart from that, you also have a other type of bar diagram such as duodirectional bar diagram. So in this case, the diagram is on the both the sides of the baseline. So either the diagrams can be on the top or the below the baseline. So when you are having bars on the top as well as the below the baseline, it is called as the duodirectional bar diagram. So these two parts represent two different characteristics. So one part represents the one part of uh, the the bar which is above the line represents one particular characteristic feature. The other part of the bar which is below the baseline represents the other part of the value. Now, for example, here the male and female data is represented on the baseline. So the red color one which is above the line represents the male data. The blue color the bars which are representing the female is below the baseline. So this is what is called duodirectional. So duodirectional means here bars are extend in two different directions. Then you have a deviation bar diagram. So in these diagrams, only deviations or differences are shown instead of representing the original data. That means here we try to show the deviation, whether deviation is increasing or decreasing. So this data is plotted on the deviation bar diagram. So other one is a broken bar diagram. So this diagram is used when values of some variable is very high or low as compared to the other one. So in this case, the bars with the bigger items or items may be shown in broken. That means if you are representing multiple the values of a particular variables, if some values is very high, it can be differentiated from the lower values with help of the broken bar diagram. So that is how you can see in this example. So data of C and E bars are broken in order to show that these particular two values are representing to a larger extent as compared to A, B and D values. So next one is two-dimensional diagram. So two-dimensional diagrams are those where the length as well as the width of the bar both and the area are considered. That is length and breadth of the bars are taken into consideration. So these diagrams are also known as area diagrams or surface diagrams. So here we have a rectangle diagrams. So rectangle diagram is one where both length and width are considered while constructing it. So these two sides represent two different characteristics of the data. Similarly, we also have a square diagram. So here the area should be proportional to the magnitude of the data. So for square diagrams, the square root of the given figures will be given and the measurement of the sides of the squares are taken. So here the shapes of the diagrams will be in form of the squares actually. So next one is pie diagram. Now pie diagram is constructed by taking the overall measure of the circle, and we know that the total measure of the circle is 360 degrees. The given values are converted into degrees and it is plotted on the circle by using the protractor. So this diagram is also known as the subdivided circular diagram. That is, circles are divided into various segments or sectors, each sector representing a particular value. Now, this is called pie diagram because a part of a sector represents a pie, and with help of a circle, we're going to draw a circle, and sectors are differentiated. So, different values are differentiated by different sectors. Now, for example, in the example, you can see the overall representation of different subjects here. Now, here the entire circle measure is 360 degree, that is divided into different segments. So we have a science, social sciences, Hindi, English, and mathematics, and these particular values are converted into degrees. For example, mathematics is 90 degrees, social science 65 degrees, science is 80 degrees, Hindi 70, and English is 55 degrees. So in order to construct a pie diagram, now we have to first find out the values, and these values have to be converted into degrees. Now, how do we convert that into degrees? So we have to use this particular pi diagram formula, F divided by N into 360 degrees. Now, what is the proportion of that particular value in the overall value? So that particular value is multiplied by 360 degree. It gives the exact quantity of the measurement of the sector or the pi. So that is how you have to do it here. Now, in this particular example, the degrees are converted into the fractional marks. Now, here you can see the mathematics representation is 135 values. English is 82.5. Hindi is 105. Science is 120. Social sciences is 97.50. Now, if I want to represent these values in form of diagram, so first of all, I have to add these values, and you can see the total of all these values come to 540. Suppose if I divide 135 divided by 540 into 360, I'll be getting as a 90 degree. So that is how you have to convert the values into degree. Now, next we go to the three-dimensional bar diagram. The three-dimensional bar diagrams are those in which three dimensions are taken. What are three dimensions? Length, breadth, and the depth or the width is taken into account. So this is also known as cubical bar diagrams. It may be drawn in form of cylinders, blocks, or spheres. So next one is a pictogram. So pictogram is a technique of representing data through appropriate pictures. So here the sales of books are represented by using the picture of books. The population of people are represented by using the picture of human being. So like this, pictogram looks very attractive compared to all the other type of diagram because we'll be using different pictures, and these pictures prove very attractive and very effective in representing the values. So they create a lasting impression in the mind of the statistician or the user of this particular diagram. The next one is the cartogram or map diagram. So cartograms are used to represent data on geographical basis. For example, in order to represent the date of fall or approximate quantity of rainfall, you're going to take the world map. So as predicted by the meteorological department, so the different densities of rains are measured here. You can see the dark red color represents the more quantity of rainfall. The medium red color represents the moderate amount of rainfall. The least one is represented by the light pink color. So here differentiating the colors, you can represent the different quantities of values. So these diagrams are very attractive and effective if message is to be communicated to a common people. So if you have a large amount of data, if you want to communicate this data very easily to common people, in such cases we can go for cartogram or map diagram. So what are the advantages of diagrammatic representation? So it is very attractive and impressive, simple and easy to understand. Even layman can understand it, and it is helpful in making comparisons. So they save much of the time and energy. So diagram leave a good visual impact in the mind of the statistician or the user of this particular diagram. Diagrams are a very clear representation of the data. So what are the limitations of diagrammatic representation? So the limitations is it can be misused very easily, useful only for comparative studies. So diagrammatic representation can be used for making comparisons. So comparative studies can be done. So if you want to do an individual analysis, it may not be very appropriate. Only limited set of data can be represented in form of data. So if you have very less quantity of data, it is very easy to represent. But more quantity of data, so diagrammatic representation not be a very appropriate tool. So difficult in representation data with greater accuracy. Since we are using statistical values, we are using averages here. So the accurate representation of data may not be that much useful. and the very limited amount of information is given in the diagrammatic representation. So like this, so these are the 5 different limitations of diagrammatic representation of data. So next we go to the graphs. So graphs can be defined as a pictorial representation of diagram that represents data or values in a organized manner. So graphs is also a pictorial representation, just like a diagrams. Here we're going to plot these values using a graph sheets. So that means the representation of data or values is done through plotting of values on a graph sheet. So the points of graphs often represent the relation between two or more things. You know that graph we're going to use the 2 different coordinates normally. One is x-axis and the y-axis. So these 2 different coordinates can represent 2 different relationships. So important the graphical representation of data used in statistics are bar diagram, histogram, frequency polygon, cumulative frequency curve, and Ojai curves. So what are the uses of graphs? So it is very easy, more convenient, quicker to draw inferences. Comparison data becomes easier, just like diagrams. Helps us to understand any data very easily, explains the statistical data. So the first type of graph is histogram. It looks more or like a bar diagram, but only difference between the bar diagram and histogram is in bar diagram there are uh, empty spaces between the bars. That means the one bar to other bar there will be a empty space. Whereas in histogram all the bars are stacked next to next. Here you can see all the bars are very compactly placed one after the other. So therefore it is called as the histogram. So histogram is a type of a bar diagram where the bars are stacked one to the next one without any spaces. That means when you're putting bars one after the other without any spaces, then it is called as the histogram. So in histogram, the scores are assumed to spread uniformly over entire interval and the area of each rectangle. So this is one thing you have to measure. The base of which equals the length of the class interval and height of which equals the number of scores within the given class interval. So it basically means normally we take the class interval on the x-axis, frequencies on the y-axis. Based on that, we're going to plot the values in histogram. The next one is frequency polygon. So it's a line graph of class frequency plotted against the class midpoint. That means we're going to take the frequencies of a particular class interval. We're going to take the midpoint of the class interval. That point, midpoint, is taken for plotting. So obtained by joining the midpoints of tops of the rectangles in the histogram. Since polygon is a complete figure, it end should touch the baseline. That means polygon is basically a complete picture. That means it's going to show you where exactly it's going to start, where exactly it's going to end. So therefore, it has to start from a baseline, and the plotting of point should end on the baseline. Here you can see it's going to start from 24.5. It's going to end at 104.5. So what are the different uses of frequency polygon? So as usual, it is used to compare two or more frequency distribution. So why it is called frequency polygon? Because we're going to take the frequencies of class interval to plot the graph. So that's why it is called as the frequency distribution curve or frequency polygon. So frequency polygon is best suited one to represent the frequencies. It gives a better idea about the outline of the distribution of the frequencies within the class interval. So next one is cumulative frequency percentage curve, or it's called Ojai curve. Here the frequencies are expressed as the cumulative percents of n, that is total number of cases. The size of the classes are plotted against the percentage of the cumulative frequencies of the classes. When plotted on normal graph paper, the cumulative frequency curve resembles an S shape. So it looks like an S shape. Here cumulative percentage frequencies are usually taken on the y-axis when we take the expected upper limit of the class interval in the x-axis. So Ojai curves can be two types. One is less than Ojai curve and the more than Ojai curve. So in less than Ojai curve, we're going to take the less than cumulative frequencies. In more than Ojai curve, we're going to take the more than the cumulative frequencies. Now here we have the data representation. So class intervals are taken with an example like 30 to 39, 40 to 49, 50 to 59. It goes on to 90 to 99. So here the lower limit and upper limit of the class intervals, adjusted class intervals, are plotted here. So adjusted lower limit class interval starts from 29.5, 39.5, and goes on to 89.5, whereas the adjusted upper limit class interval start from 39.5, it goes on to 99.5. So the frequencies are 3851122. So here less than cumulative frequency and more than cumulative frequencies, and these percentages are taken here. Now here we have a less than cumulative frequency like 3, 11, 16, 17, 18, 20, 22. More than cumulative frequencies 22, 19, 11, 6, 5, 4 and 2. So when you take the overall the total and you convert into percentage, so the less than cumulative frequency with the 3 comes to 13.64, 11 comes to 50. So it goes on like this actually. So whereas in more than cumulative frequency, you're going to start with 100, we're going to go to the lower value. In less than cumulative frequency, we're going to start with the lower percentage, we're going to end with 100. So that is a difference. So in less than cumulative frequency, we're going to start with the lower percentage, we're going to end at the 100. In more than cumulative frequency, we're going to start with 100, we're going to end with the lower percentage. So what are the uses of Ojai curves? So it is basically to represent the percentiles, quartiles, quartile deviation, medians. So all these deviation values can be represented very easily. To find out the percentile rank of a given mark, it can be used. To overall comparison of two or more groups of some variable, the best use is Ojai curve. So Ojai curve is also used for intra-student comparison on more than one subject. So these are some of the examples where you can use the Ojai curves. So as I told earlier, what is the overall significance of the diagrammatic graphical representation? So overall significance of diagrammatic and graphical representation is it looks, it makes any representation very attractive and impressive, and they make the data more simple and intelligible, and they may be amenable for comparison. That means it becomes easy for comparison, and they save time and the labor. They have a great memorizing effect and creates a good impact on the statistician or the user of the this particular diagrammatic or graphical representation. So limitations are provides a vague ideas because these are only approximate values. So limited information can be given on these graphs and diagrams. Low precision because normally we're going to take the averages to represent data. So not very accurate values can be represented because some the values which are very fractional in nature. So in such cases, it becomes very difficult to plot it. Low precision because of the limited information restricts further data analysis, portrays limited characteristics. There is a possibility of misuse of this one. Fail to represent a meaningful look in certain situation. That means if the data have a various measurements and wide variations, that means if the variation of data is very wide, in such cases, the graphical and diagrammatic representation may not be that much appropriate. So you have to use these diagrams and the graphs very carefully. Otherwise, it's going to give a false information. So these are the limitations of graphical and diagrammatic representations. Then what is the difference between a graph and a diagram? So many times this question do come differentiate between graph and diagram. So graphs are drawn on the graph paper or graph sheet. So it is used for preparation of graphs or creation of graphs. Whereas plain paper is used for drawing, constructing diagrams. So in case of graphs, it represents the mathematical relationship between two or more variables, like what is independent variable, what is dependent variable, which is independent variable, which is dependent variable, how dependent variable depends on the independent variable. So these relationships you can represent easily in graphs, whereas in diagrams, it does not show any relationship in the variables. So graphs are commonly used to represent various frequency distributions. Diagrams are not used for frequency distributions. So graphs are commonly used by a researcher for analysis of data. So diagrams are not useful for analysis of data. So graphs are Examples includes the histogram, frequency distribution diagrams, mosaic curves, and other things. Whereas in case of diagrams, it can include like pie diagram, bar diagram, two-dimensional bar diagram, cartogram, uh, pictogram. So like this, we have a different types of diagrams. So this is the broad difference between graphs and diagrams. So thank you very much. I hope that you understood the importance of graphs and diagrams, the difference between the graphs and diagrams, different types of graphs, different types of diagrams. So don't forget to subscribe my YouTube channel, RJK Tutorials. Thank you very much.